All right. In this section, we're going to begin looking at quadratic equations. They're functions. You've done quadratic equations. They're really similar. You're just replacing the y value with f of x. Explain the advantage of writing the quadratic function in standard form. So the general form is ax squared plus bx plus c, which is very familiar. And the standard form, which hopefully you know from college algebra, is ax minus h quantity squared plus k. What makes it the standard form easier is because, one, it's easier to graph, because from the stuff we did about translation of functions, you can know how far to shift it over and lift it up and all that kind of stuff. It's easier to do in standard form, because if you have it in general form, you have to convert it into standard form to be able to do that. The second thing is that the vertex is easier to find. As you see right there in the box, h is equal to minus b over 2a, and k is then substituting that into the function. Well, the standard form, you just look at h and k and write it down. There's really no calculations to do there. Explain why the condition of a naught is not 0 is imposed for the definition. That's this condition that's right here. Right? Why does that have to be 0? Because if you didn't have the a squared term, if you didn't have a, then what would be left is a line. So it's not a quadratic equation, it's a line. For the following exercises, rewrite the quadratic function in standard form and give the vertex. So if I take number 10 here, h of x is equal to 2x squared plus 8x minus 10, what I want to do is convert this to standard form from the general form. First thing I need to do is factor out the 2, because everything that we do when we complete the square, this has to be a 1. So I factor out 2 out of the first 2. Now, when we complete the square, of course, what we have to do is, if we go back to the diagram, of how to do this, this has to be x squared. Now these two pieces have to be this piece split into 2, so that'd be 2x and 2x. So this would mean that this one has to be x times x. That's how we get that area of that square. This rectangle would have to be 2 times that x, and this would have to be 2 times that x. Now the part here that completes the square is 2 times 2, which is 4. So I'm going to add 4 here. Now, I didn't really add 4. What I added was 8, which is 2 times 4. So that means that that's what I have to subtract off, is 2 times 4. This 2, that 4. Now, this piece in here factors to x plus 2 squared, because everything in here is the area of this square, and everything on the edge, if I multiply the two together, is also the area of the square. And then I add these together, which is negative 18. So I have my standard form. Now I can write the vertex, because I know what h is. This is supposed to be x minus 2, so minus a minus makes it a plus, and that's why we get a negative 2 and negative 18, and I have my vertex. For the following exercise, determine whether there is a minimum or a maximum value for each quadratic function. Find the value and the axis of symmetry. So 18 says minus 4t plus 6t minus 1. Now all we really have to know is the a to know if it's a max or min, because if it's less than 0, it opens down, which says we have a max, like we have here. And if it's greater than 0, then it would be a min. And since minus 4 is less than 0, we have a min. Now if I want to know what the axis of symmetry is, and the actual value at that spot, we just need to find the vertex. The axis of symmetry is the x-axis of the vertex. So the axis of symmetry is minus b over 2a, so x would be minus 6 over 2 times negative 4, which is 6 over 8, jumping ahead of myself, which is 3/4. Alright, so, or t in this case, because we're using t's, not x's. Alright, because that's the variable that's in here. Now if I want to know what the value, in this case the maximum value is, I just plug in 3/4. So that'd give me 4 3/4 squared plus 6 3/4 minus 1. This would give me -4 times 9/16 plus 6 times 3/4 minus 1. This 4 divides in with one of those, so I get -9/4 plus 18/4 minus 1. Get a common denominator, of course. That'd be 9 plus 18 minus 4 all over 4. So this is 9, subtract 1, that's 5/4. So our maximum value is 5/4. So x squared minus 6x plus 10 equals 0. Now, if we're assuming that it'll probably be complex, then we don't even need to try to factor it. We can just jump straight into the quadratic formula. So remember, the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, this would be minus -6 plus or minus the square root of -6 squared minus 4ac all over 2a. Alright, so now what I could do is I could simplify that. That's 6 plus or minus the square root of 36 minus 40 over 2, which 6 plus and minus the square root of, and this of course is -4 over 2. 6 plus and minus the square root of 4 is 2, and square root of -1 is I. Divide 2 into each one of them, so we get 6 over 3 plus and minus 2i over 2, which is, 6 over 2, which is 3. Sorry, jumping ahead of myself. And then I. So we get 3 plus or minus I. Alright, how can the vertex of a parabola be used solving real-world problems? Well, in a parabola, the vertex is either the maximum value or the minimum value, and so if you're trying to maximize something like profit or minimize something like cost, or you're trying to maximize area, then that's where it's used. So here's 2 examples. Let's go do those. Alright, let's do 86 here. Find the dimensions of a rectangular corral split into 2 pens of the same size, producing the greatest possible enclosed area given 300 feet of fencing. Alright, let's assume this, because they do kind of leave one little thing here vague, but we'll go like that. This should be okay. Now what we do know is we're trying to maximize the area. So that means we need to know what the area of a rectangle is, which is x times y. If we call this side, say, x, and we call this side, say, y. So that would be the area. Now, there's another part of this, and that's the constraint. And what's constraining the area is how much fence that we have. Well, it says that we have 300 feet of fencing. Now, the other thing that we know about the fencing is that it has to be made up of 2 x's, 1, 2, and it has to be made up of 3 y's, 1, 2, 3. Alright, so that tells me that 2x plus 3y has to add up to the 300 feet of fencing. Now I solve for one of the variables. Say I solve for y. So I subtract over the 2x, divide by 3, that would give me 100 minus 2 over 3x. Now what I'm going to do with this is I'm going to substitute that in for the y here. Now what that's going to do is give me this equation that looks like ax times 100 minus 2/3 x distribute 100x minus 2/3 x squared. Now this is the area now is a function of one side, which is a parabola with a negative a. So that means it opens down, so it means it's going to have a maximum, so all is good. So now we just need to find what the x is. So that's minus b. Now this is the b because that's on the linear term, over 2a, which is going to give me, minus, forgot that. The minuses become a plus, so we have 200 over 4/3, which is 300 over 4. And 4 goes into 300, well, 2 goes into 150, and then a half 150 is, 75. So x is 75 feet. And what would y be is I go back and I plug it back into this value into here. So I'm going to get y is equal to 100 minus 2/3 times 75. Well, 3 goes into 75 25 times. And 25 times 2 is 50, so 100 minus 50 is y is 50 feet. So that gives me the dimensions of 75 feet by 50 feet. Alright, let's do 90 here. Suppose that the price per unit in dollars of a cell phone is modeled by the equation P is equal to 45 minus 0.0125x, where x is in thousands of phones, and the revenue is represented by P times x. So in other words, plug that in for P, which would you get 45 minus 0.0125x times x. Then distribute, so our revenue function in terms of the unit is 45x minus 0.0125x squared. Now that we have that, we can find the units easily because it's just at the vertex. This is opening down, so I know it's a maximum. So x is minus b, which is the term on the linear one, divided 2a. Plug that into our calculator. Times negative 0.0125. So we get 1,800. We get 1,800 units, thousands of units actually. So x would be 1,800,000, so that's 1.8 million units.